Hi all, my name is Alex. I'm one of the co-founders of PRIZ Guru. Uh, Today we wanted to demo something that we've been working on for a while, and it's an expansion or an improvement for one of our most powerful tools, probably one of the most powerful tools called functional modeling. Functional modeling, for those who don't know or new to this field, functional modeling, it's an analytical tool that allows us to model the system, model the problem space with its components and the functions between the components, and of course the product of the system. It allows us to understand where the problem coming from, and that's typically from a zone of conflict inside the system, and ultimately solve the problems and innovate. Now, the typical process of building a functional model, it starts from understanding or describing even to ourselves what the system is about. What is it we're trying to analyze? In this case, as an example, we took Tesla Model 3, right? And we pulled this description from LLM. There's some high-level components in here. There's not too much details. There's a little bit of detail for every component in here, but overall, again, it's a high-level description. There's an image of the car, and that's about it. Now, think about it. This is important to have when we working with people, right? We documenting, we putting it somewhere in the Word document. Here's our system. This is how it works. Here's all the components. Here's what they do, and so on and so forth, right? So we usually in a well-organized project, we do have this documentation lying around somewhere. Now, the next step, once we have some level of understanding of the system, we want to start with actually modeling. And this is where the problem begins. What we see with a lot of engineers that we're working with, it's two problems. First of all, nobody wants to start with blank canvas. It's very hard. They know that they're going to invest a lot of time now until they get to the actual important work. And by the time that they do get to the important work, they're so tired and so frustrated, they don't want to move any further or deal with that. They typically fall back to brainstorming in the best case, or they just go home. Now, what we've been able to do lately with this improvement, we've been able to use AI to help us build this initial draft of the model. Now, again, the description is very important for human beings to understand what the system is about, but it's also, of course, important for the machine. And what we built, first of all, is some level of validation how well this description is built. Again, for LLM to understand, for the agent to understand, as well as the human to understand. So is this enough information in this page to describe the system that we're trying to analyze? In this case, nice, we've got a nice green mark. There are some critical gaps that it lists, which is fine. We're always gonna have some gaps, and again, that's okay. You're never gonna get to 100% coverage, but it's good for us right now to start and build the model further, again, as human beings as well as the machine. Now, the next step, what we are able to do now, is actually build the model in the click of a button, something that typically takes hours, days, sometimes even more. We're able to draft this model in under a minute. So let's give it a few seconds. Okay. So we built a model. Now, this model is, again, it's a good, solid draft. It has components. It has it has the functions in between them. It already has some starting point that people can start playing with and improve on. Now, we already have some rankings, like HVAC, for some reason, it has the highest functionality, right? Where inverter has no functionality, which is weird, right? We know that in Model 3, it's actually pretty important piece. Now, let's take this as an example, and we're saying that passenger is the product of a system, which is true. Car is built to move passengers, to move cargo, move something, right? Then there is driver as well, and the driver is marked as super system, so he's not necessarily part of the part of a car, which is true. But I want to change it a little bit, and I want to say, you know what, the touch screen is actually informs the passenger, right? Informs the passenger, and I don't want driver. In my mind, the driver is the same as passenger, so I don't need the driver. Um, But what else the touchscreen does? The touchscreen also distracts the uh, distracts the passenger or the driver, and it's not necessarily a good thing. It's a harmful function. So we start playing with this model, but not from scratch, not from zero. We start building it from some boilerplate already ready to go set of components, and we start improving on that, and we can analyze that. Now this is good, but we can go further and we can say, you know what? I don't have the full description. All I have is an image, right? And in this case, it's an image of a human heart, the parts of the human heart, the coronary arteries of the heart, so some peripherals of the heart. And that's really all I have. Okay. Now, same here. In my mind, is this enough information for me to go forward? Me as a human being, I think it's enough. I should be able to build something. And in fact, yes, we're getting a green mark. Great. Again, there are some critical gaps in there that the system identified. Okay, but I can move forward with modeling. Same story here. I can say, build a draft of a functional model, and I'll start from there. So something that, again, as I mentioned, it takes hours, days, sometimes more to build a functional model. We typically get it here in under a minute. So let's see what it builds for us. Okay, so the product here is blood, which is correct, which is absolutely correct. There's a bunch of components, a bunch of super systems. Now the model is it a perfectly modeled system? No, it's mostly incomplete, but it is some starting point that people can start working on. Okay. Now the interesting part that we can say, you know what? It's not just a human heart. It's a human heart after a heart attack. Now that's where gets interesting. First of all, the validation will say, heart attack, but which one? What was damaged? What type of a heart attack? And of course, we're getting a little bit less mark on the validation piece because uh, we're missing context. We missing what actually been damaged as part of the heart attack event, right? But even in this case, it was enough for us to at least start building the model. And what the model will do, what AI will do in this case, it will use the images, but it also will use some commonly known information about the heart attacks, maybe statistics, and so on. It takes a little bit longer, but think about it. When you're trying to dig that information, it takes literally hours and hours and hours to get that information, to get statistics. Here we're getting it in minutes. So now it's a completely different picture, right? Here it's all nice and blue and functional, which is too perfect typically. But in the other one, we're all of a sudden getting some problematic components. Again, incomplete model, so we can start and improving on that model. Here's the blockage, whatever the blockage is. Here's the myocardium, which is not functioning correctly as a result of heart attack. That was the decision of the LLM. Now, what LLM did with this model or with this system, with a heart under heart attack, it brought something that's statistically significant enough to describe a heart attack because we didn't provide any details. But if we were provided any more details, what type of heart attack, what was damaged, and so on, it would build the model much more precise. But this is what we wanted to show you. We're enabling building the base functional model from scratch without any particular knowledge at an extreme speed. And from here, people actually can start working on something that matters and not dealing with the boilerplate work. That's about it. And we'll see you next time. Thank you.